In this screencast, I'm going to provide a brief overview of the new features in Persyst 14 Spike Review that are introduced with revision D or later. In a nutshell, it's about making the process of evaluating the homogeneity of spikes within an average a much more efficient process, without having to do this in two Persyst programs, namely Spike Review and then Voltage Plot. With P14D, you can do this much more easily, and in this screencast, I will show how to do that all within Spike Review. My name is Michael Guess, and I am the VP of Research and Clinical Applications for Persyst Development, and this screencast will be much more of an overview of the new tools rather than a case study. And so, the example we'll be using for our brief overview is a straightforward one. It's a 24-hour recording with spikes that are primarily occurring during sleep. And here's a quick peek of the new Spike Review. Here I have one of the spike groups displayed along with a selection of spikes, all overlaid individually to see how similar they are. Now, Persyst Spike Review automatically sorts spike detections into clusters or groups of spikes by the focus determined by the P14 spike detector. And so we're going to go ahead and go through the process of how we arrived at this. And to do that, I'm going to go ahead and clear my work. And so I'm going to restore this back to showing just the individual maps rather than propagation. And I'm going to click the unconfirm button to clear all the selections that I've made. And I'm going to even return this back to a montage that is a typical default montage when you launch Spike Review, and even sort these by time rather than amplitude. In this way, as we go through this, I can show why these settings are optimal and these new features that allow you to sort spikes differently and to create your averages. So let's go ahead and close this. We're back into P14 in the main display. And of course, with spikes, there are several questions. One of them, are there spikes? The next one is, where are there spikes and how frequently are they happening? And so you can get a sense of that to some extent from the trends. Here we have a patient that they're going to sleep at this point. You can see the alpha fading away here. And then as you go a little further along, you'll see various sleep patterns. If you were to go page by page through this, which we will not, so that we can get right into Spike Review. But this patient has left temporal spikes, and then they increase in frequency until there's a seizure here at this point, which you can see. Now, spikes are listed on the right. We can certainly go to the spike or the comment filter at the top, change this to spike detections, and get a list of all the spike detections by time. We can sort them by perception or probability, focus, and amplitude, duration, angle, all that information. It's a lot of information on every single spike, and going through those one at a time would take a considerable amount of time. Spike Review takes all that information and organizes it in a logical way. And so this first screen is very similar to previous generations of Spike Review, where the spikes are sorted by the channel in which they are detected and in decreasing order of detection. So in this example, we have T3 with 1,159 detections, and then it decreases numbers as we go forward. So some of the new things that are in version C and later are you have an ability to select all spikes, which would include spikes that are detected during seizure detections, or the default, the new default, which is interictal only. And so what this will do is show spike detections that do not occur during a seizure detection simultaneously. So that's the first change. The next one is you can change how they're ordered. Now in this first display where we're showing the spike groups, sorting them by count works pretty nicely, because then we have the spikes with the greatest number of detections, or the channel with the greatest number of detections right at first. So I'll go back to the overview. And as you can see, when you click on this one, it'll take you into that average. And so that's the first step, is we'll go into the first average, and you can use any montage you like to evaluate these. And one of the changes in P14D is you can now sort montages, create your own montage groups. And I have quite a few montages on my system for 1010, for intracranial, for 1020. And this allows me to sort them into different categories so that I can find them a little easier. And for this example, I'm going to go ahead and put this into an average 12 reference. And this one I've renamed and given it reference average 12 longitudinal EKG, because I add an EKG channel to the bottom of that, which is handy. And the next thing I'm going to do is I'm going to go to the sort. And this is particularly important when evaluating spikes. Traditionally, these are always sorted by time, but as it turns out, it's rare that the exemplar spikes are right at the beginning of a recording. And so there are two other sorting options that have been added since version C, and that's the ability to sort by amplitude or by probability or perception value. We find that for scalp EEG, sorting by amplitude works pretty well, so that's what I'm going to go ahead and start off with here. And of course we can change gain, montage filters, but we're going to start with this. And the next button I'm going to look at is the ability to select the option to show an average over a confirmed average. So selected average over confirmed average. Right now I haven't selected any spikes, so it's blank. Now this first spike looks like an exemplar. There's not a lot of other random influences altering the first half wave or second half wave of the spike. And so I'm going to go ahead and confirm this as a spike. Now the next task is say, all right, I'm going to add spikes to this average, but I want to see that they're very similar to the first one. And not that they just show up in the same channel, but for this particular example, I want to see that the first half wave and second half wave of the spike line up nicely for this, and that there aren't any differences in propagation. We'll look at that feature here once we get going. So step one, confirm a spike, and then the next thing is to select a spike. And so this average shows the confirmed average, of which there's only one at this point, and then it says, well, what happens if I were to compare these two and see if the first half wave and second half wave, if these line up very nicely. And if I decide that's not the case, I can go to the next one. And here I can see some random influences are affecting the spike takeoff here, the first half wave. And so maybe I don't want to select this one and add it to the average. Same thing with this, even more so. That first half wave is considerably different than my exemplar that I picked as the first one. And so what I can do is move along until I find one that overlaps very nicely. And since that's the case here, I'm going to go ahead and check the confirm box. So the process is select, look at this to see if they overlap well. If they do, check it. If not, move to the next and the next. So I'm only going to confirm the ones that line up well. And what this does is it combines two things. Traditionally, you get all the spikes together in an average, and then you'd show the overlay traces to see, well, do I have outliers? Here, you can eliminate those outliers right from the beginning and do that visually. And by doing it visually, you decide what parameters are important to you for whatever particular application. If you're doing source localization, well, you want them to have the same spike focus, and you also want to have a consistent first half wave, second half wave, and you want the fields to be similar and the propagation to be similar. And so in addition to just looking at a voltage topograph, you can select propagation maps, and that's this matrix button here. I'm going to open this up just by sliding that over a little bit to the right. And now you have a time series that you can look at as you're confirming them. So if I click the gear button to the upper right, this is just set for 3 rows, 3 columns. As you can see, my delta here for each step is 10 milliseconds. You can set that to a different value if you like. But what we have is time 0, the peak of the spike, right in the middle. And then this increments 10 milliseconds at a slice. 10, 20, 30, 40 milliseconds. You can go backwards. 10, 20, 30, 40 seconds with a minus sign in front of those. So minus 10, minus 20, and so on. And so where the spike is starting here is not changing as we step through the spike itself. And so it's not propagating. Now if I were to select one where it was starting in a different area and then moving, then that would indicate that that is a different spike than the other ones that I've confirmed. So I wouldn't add that to that particular average. It just gives you one more visual to compare the spikes as you add them to the group. Same process. Select one, see if it lines up nicely. And if it does, you can add it to the group. And then once you probably have a dozen or so confirmed, you've got enough for most applications, but again, you decide how many you want to mark. I'm just going to go ahead and confirm a dozen of these. Right now I have 7. It says n equals 7 at the top of that. And for this particular example, I want to look at that first half wave and get that nice and consistent for my average. And since there's quite a few spikes at this particular group, then I can afford to be picky. Now, something to keep in mind as well, if you have quite a few spike detections, but at some point in the recording an electrode became dislodged, even if the focal spike lines up very well, but you've got a bad channel, just as well not to use that. The idea is to have a nice clean average. So there we've already marked 12. So if I were to go forward another page, spikes, you can see that I'm just going to look here as I select each one of these. So the process can actually go pretty quick. So I'm just evaluating that first half wave, but again, you can look at propagation maps too and see if they're looking considerably different. So now I have a number of these marked. I'm going to go ahead and go back to the overview, and there are a number of other spike groups that bear looking into further, but I'm going to go ahead and jump forward a page on this and go ahead and look at this P3 group. So I've marked some T3s rather. We'll go into this one, this group. If I click this grand average, I can see I have n equals 21, so there's only 21 in this group. I don't have as many to choose from. So let's go ahead and select this middle button again, selected average over confirmed average, which means we go ahead and clear these. I confirm this first one, and then I look at the second one to decide, does this match? Does it line up very well? I can change gain if I need to, which in this case would help. And that's a bit more different than I would like, so I'm not going to use that one. Let's check this one. And again, I don't have as many to choose from. So we'll go ahead and confirm this. But the idea is to find ones, if possible, that are as consistent or similar as you can find. And even with a fairly small group like this, we're having some pretty good candidates to do that with. Okay, so this one I've selected 8 for this. Go back to the overview in the upper left, and if there are no more groups, in this case we would be digging into some more of these, but we'll stop here. Let's go to the final report. And like previous generations of spike review, these are the 2 groups that I've confirmed spikes in. It says T3, n equals 15, P3, n equals 8. That's the number that I've confirmed. The individuals from those groups are laid out after that. And if I click on this, it takes me into that average. And this is where I can select this third button. I could have done it earlier as well, which is going to show me all of the detections. Let me change the gain here. So these are all the spike waveforms that I've confirmed, laid one on top of the other, and I could look for outliers and decide, yes, if this one has a nice average, and then if I need to add or remove any from here, I can do that. So I can page through this and see if there's ones that I want to remove from that. And to do that, instead of sorting by amplitude, I can select confirmed first. So now all the ones that I've confirmed show up here. And you can see there's a bunch of noise down here because while I was looking at this upper channel, the T3, I looked past the fact that this was during part where we had electrode artifact at F8. So I can unconfirm that, and it gets rid of that noisy channel. So that's the last option that you have here, which is you can sort them by amplitude, but you can put your confirmed first if you want to go back and say, I want to remove one of these from that and clean up that average a bit. Let's go back to final report. Here's our P3. Again, we can do the same. We can look at this and everything looks good. So at this point, I'm done. I can go back to Persyst, I can close the program, and that's saved. And using Persyst ESI powered by Epilogue, those spike averages will be used as part of generating the source localization. And you can also export those groups that you've created by selecting the Tools menu and then select Export Groups to EEG page. So rather than the Options menu, so let's go to Tools, Mark Groups as VPlot, and those two groups have now been marked. So when I close Spike Review and display all, and then sort them alphabetically, there's my group 1s, which are all my T3s, and then group 2s, which are my P3s. And that's the process of using the new Spike Review. If there's any questions, please contact us either through email, or you can go to persyst.com, Persyst.com, and we'll be happy to answer any questions.